Everybody, so today is the day and I'm so excited to be doing this test almost basically live, recorded for you all. I am looking forward to this test as much as anybody. This is the LF Audio High Precision Amplifier. This is a prototype. This is not what the final version will look like. This is literally a Frankenstein put together in a case just so we could get some proper testing. This will go out in the field so folks can play with it and give me feedback. But the high precision amplifier will come with a touchscreen LCD in the case itself. It will come with the LF Audio wireless volume controller bass knob, so you'll get all the data telemetry and control with your knob. And in fact, you'll get the dual knob, right, if you get the multi-channel version. The circuit will have a bunch of different telemetry that you'll have at your fingertips. So it'll have all the wireless, the RL sync technology to connect with other devices like the wireless data display, smart fans, all of that fun stuff. It will measure incoming voltage and amperage. It will measure outgoing voltage, amperage, impedance, and wattage. It will tell you the real-time efficiency of the amplifier. It will do signal analysis just like the WVC Pro, detect clipping, all of that great stuff. So a lot of things you've never seen in an amplifier, except the prototypes I've shown. This will be all built in to the LF Audio unit. Now, this unit is meant to compete against the Brax RX2 Pro. So we are aiming for insanely low THD, super SQ-oriented amplifier. Not for subwoofers. This is just for somebody who's looking for the best you could get for your mids and your highs, of course, SQ setups. So today what we're going to do is we're going to do some power tests, and I'm excited to find out what it can do together. So we have a voltmeter on the input, so we could see we're at conservative 13.4 volts, so nothing crazy, right? Standard alternator system you could find in a standard automobile. You don't have to go crazy with the voltage. We've got the output going to a resistor bank. These are 100 watt resistors at 2 ohms a piece. We're going to start with a 2 ohm test. So we have 2 of them in series and then 2 of those banks in parallel for a final load of 2 ohms. So we're going to do some power tests there. We have our little power meter connected so we could see the real-time amperage, wattage, and voltage. We have our oscilloscope hooked up so we could confirm everything is accurate. And then finally, the measurement device is our QuantAsylum 403. So what we're going to be doing is pushing up to 18 dBV into the unit. Sorry, that's the output we can measure. So this allows us anywhere from 0 to 18 to get the cleanest measurement the device can offer. Once we jump to higher power levels, we're going to lose some fidelity because the unit has to use a voltage divider, but we could still get an idea of whether or not we're meeting 0.1 THD as most amplifiers do near their power levels. So let's get into it. I'm super excited to do this and see whether or not we could basically break some records here. Again, goal is getting it cleaner than 0.1 THD. I'm hoping for at least 0.001. That is sort of like an incredible benchmark, which will, of course, warrant the name of a high precision amplifier. So just to review how I do my test, I do 100K fast Fourier transform. I normally use the BH window for you guys that understand what this is all about. And we're going to generate a 1 kilohertz signal, which is standard. And here I have tied the signal and the voltage of the preamp so we can output just the right amount of voltage at the limit of the QuantAsylum. So let's go ahead and start the run. Now what we're going to see is that we are getting 11.2 volts out and 7.6 volts RMS at our 1 kilohertz frequency as expected. We're showing here, let me jump through this so we could look at, there we are, 7.6, 3.6 amps. All right, this thing is not showing me the right amount of decimal places, but that's okay. We calculate that we're right around 26 watts or so. So at 2 ohms, 26 watts. Let's start our run and see what we're doing. Currently, we are looking at 0.00095 total harmonic distortion plus noise. So we beat our 001, we're below that, at 26 watts. Let's up the power. So we're going to have to use a divider here. And again, you can see right away we lose fidelity because that's the nature of the device, unfortunately. So we can't measure that low, and I do not have a more expensive device to do some measurements. But let's do, we're going to go significantly higher. All right. So let's see here. We're looking at RMS of 14.3, 20 volts peak. Definitely feeling the heat coming off of this. So let's go through it again. 14.4 volts out at 6.73 amps. So that is 14.4 times 6.72, 100 watts. So at 100 watts, start the measurement. 0.00135%. Unfortunately, we are likely cleaner than this, but once again, even when I stop it, you can see that the device has literally a floor. It cannot measure lower than that. This is the floor using this voltage divider, so I need an audio precision, which I don't have, but we could see that worst case scenario, while maintaining our floor, our ability to measure, we're at 0.001%. So let's continue upping the power a little bit. And let's see how high we can get it. All right, so now we've upped it to 23 volts max, 16 volts. So there we go, 16 times 7.5. So 16 times 7.5, we're up to 120 watts. Maintaining 0.014. All right. Let's increase the power a little bit more. All right. We're at 0.002 at, if we look at it, let's see, 1772 times 8.14, 144 watts at 0.0289 THD. This is all at 2 ohms, so let's try some 4 ohms. All right, I disconnected the secondary capacitor bank, so we're now at 4 ohms. We're running at test at 7.92 volts and 1.8 amps. So that's right around 14 watts. 0.008%. All right, let's up the power. Once again, we're going to lose fidelity once we do that. So we literally cannot measure cleaner than this. So we might be cleaner, but QuantAsylum won't let us measure that. As you can see, all I had to do was literally change the input, and we lost all that fidelity. But let's go ahead and up the power. All right, we're now at 18 volts RMS, 26 max. So that's 18.36 and 4.14. All right, so that's 76 watts at 4 ohms of impedance at 0.00145. Again, we're likely cleaner than this, but QuantAsylum won't let me test anything lower. So there we have it, an amplifier that per channel, so far with the prototype, we've been able to test well over 200 watts with at least 2 zeros of precision. So we know it's cleaner than this because you saw the QuantAsylum. So 0.001% or better. So here's a quick look at the amplifier chassis and the resistor load bank right after the runs. We did not measure the input amperage. I should have done that. But we could see here that this has shown us that this is likely an incredibly efficient amplifier. So I'll do more tests in the future. Stay tuned.